So here today, what we're going to do is talk about two independent populations. So this is an extension of the time when I was referring to two independent population means to be able to include two independent population proportions. Another thing that's really different here is when you have a response variable that's categorical binary, right? However, your explanatory variable is still categorical binary. Okay, so let's go ahead and run this app. So we run it, two independent populations. Here you can distinguish between two independent population. Between the proportions versus the mean by specifying your response variable. Okay, so if you do quantitative, you can change the mean information, its standard deviations, as well as if it is a pooled t-test or a Welch t-test. But then if it's categorical binary, we just have to input the frequency. Okay, input the frequency. So let's just go ahead and run this. So go ahead and calculate this. Okay, this little overlap, that's fine, but let's just separate things a little bit. Let's make it 20. Okay, so here, this is my test statistic, right? I'm able to see my test statistic and compare it to my critical value. And then here is my summary. I'm doing the two independent population proportions. Here's my test statistic. Here's my p-value, and here's the standard error. Great and fantastic. So let's say there's a big difference between these two proportions. Let's be dramatic. Okay, so take a pause. This is not class, but you can imagine, take a pause. What do you think is going to happen? Okay, the test statistic should not show up on this map because there's a huge difference between these two. The test statistic is so small, it does not appear on this curve. Okay, that makes sense. However, if this little overlap is going to happen, I'm okay with it for now. I'll change it later. But let's say these two values. Oh, well, that's fine. Let's keep it that. 12 here, we would actually decide to fail to reject our null hypothesis because we haven't garnered enough evidence to reject the null hypothesis. However, when it was back to being 30, you would have rejected the null hypothesis because the likelihood of those two proportions being the same is really unlikely. Okay, so that is that.